is learn how to work with these graphs and do transformations. So part A says to graph log base 2 of x, I stroke out table of values. You don't need a table of values. You can graph it directly. Again, all parent log graphs have the following two things every single time. They always have x equals 0. They always have the point 1 comma 0. Then since this is a base 2, you're going to have the point 2 comma 1. And next, we want to graph y equals log base 2 of 2x minus 1. And what you have to recognize when you're graphing a log graph with transformations is, what was the parent graph? Well, that's easy to see. Can you see that the base was 2? So here is our parent graph written in the equation. Log base 2 of x. It's important to see the parent graph because now we look, well, what other numbers are present? There's a 2. That's inside the function. And you see that would be a horizontal compression. You'll multiply your x values by a half. Then there's a 1. And that 1 is outside of the function. If they wanted this minus 1 to be inside the logarithm, brackets would have to be added to this. So this is a vertical translation, 1 down. And our technique for doing this is the same as we use in transformations. We're going to take our 2 points on our original graph. We're going to draw our arrows, first for stretches and compressions, then for translations. Label that the only thing we're doing here is x by half, and the only thing here is 1 down. This will be 1 comma 1 and 1 half comma 0. 1 down, this will become 1 comma 0, and 1 half comma negative 1. We are also going to look at what happens to our asymptote. Do you remember in exponential graphs that had a horizontal asymptote, that the only thing that changed it in an exponential graph was if you moved it up or down? Now in a log graph, we have a vertical asymptote. Can you see the only thing that's going to change that vertical asymptote at 0 is if you moved it left or right? We are not moving it left or right. We're just moving it 1 down. So in this example, it's going to stay at x equals 0. Now, I changed the instructions to graph it on a separate grid. If you try to graph too many things with asymptotes on the same grid, it gets confusing. So we're going to have an asymptote at x equals 0. Label our points. We have a point at 1 comma 0, and we have a point at a half negative 1. And draw your graph through those points. Finally, in part C, it says identify the intercepts. So we have an x-intercept at 1, 0. No y-intercept. The equation of the asymptote is still at x equals 0. And the domain and the range. X is bigger than 0. And the range is everything. Now I'm going to get you to circle questions 8, 9, 10, and 11. But before we finish this section of the video, I'm going to get you to turn to page 400 and try 2 on your own. Here's the first one. So graph y equals 4 log base 3 of x plus 1 minus 5. All right, let's see how you did on this first one. So the 4 is outside the function. That'd be a vertical stretch. The 1 is a horizontal translation. The 5 goes 5 down. You think and draw a quick sketch of the base graph, which is log base 3 of x. Then you can take the points 3, 1, 1, 0. Do the transformations. Those should be the points you end up with. And then take those points, and your asymptote, since we are moving 1 to the left, is going to change. Label your 2 new points, label your asymptote, and then you can draw a graph through those points. So we have to write it in factored form. Taking that half out would leave you with an x plus 4. And there's the graph of the natural log of x. It has the point e, 1. So same thing, we do our stretches and compressions first, then our translations. And with e, you would just leave e in your answers. So in the end, you get the point 2e minus 4. And if you're wondering, where do you graph that? Well, e is about 2.7. So if we just do some approximation, 2.7 times 2 would be 5.4. 5.4 minus 4. This is going to be roughly at about 1.4. So we label 1.4 comma negative 1. Draw your asymptote, label the other point, and you can draw the graph.